Ask my instructor 4.4.16. A fence 10 feet high runs parallel to a tall building and is 22 feet from it. Find the length L of the shortest ladder that will reach from the ground across the top of the fence to the wall of the building. The constraint is given by the fence that blocks easy access to the building. Let x be the distance the foot of the ladder must be from the fence. Because x is distance, it will be 0 or positive. Notice that we have similar triangles. Similar triangles have the property that the ratio of their sides are equal. And so we end up with a very nice equation that links h and x. And the constraint gives us a way to write h in terms of x. Rather than finding the shortest length, let's find the shortest square of the length. So instead of finding the square root of the sum of the squares of the sides, let's instead use as our objective function the sum of the squares of the sides. What I'd like to do now is clean up the function. Notice that both expressions have x plus 22 squared. Factor that out, and we are ready to take the derivative. Since it's a product, we're going to use the product rule. After we take the derivative, we want to clean up the derivative, and this will take a little bit of work. Let's first factor out x plus 22. Now this line I'm going to bring to the top of the next slide, and we are ready to simplify the expression inside the parentheses. First, I distribute the 2. Next, I'm going to distribute the negative 200 over x to the third. And also, the first two terms in the parentheses, I'm going to write them as having denominators of x to the third. When I'm done with all that work, this is what I get. Notice that the two middle terms cancel. I'm going to bring this last line up to the top of the next slide. When the two middle terms cancel and I do the subtraction, this is what I get. Notice that that numerator has two terms, both of which are divisible by 2. So I factor out the 2. And I'm ready to find critical points. Critical points occur where the denominator does not exist or where the denominator equals 0. I'm sorry, I meant derivative. Either where the derivative does not exist or where the derivative equals 0. One critical point is where the derivative does not exist, which is x equals 0, but that would have the ladder sticking straight up in the air. So we look for where the derivative is 0. That occurs when x plus 22 equals 0, giving us a negative distance, but it also occurs when x to the 3 minus 2200 equals 0. Notice that the derivative is negative before the third root of 2200 and positive afterwards. So by the first derivative test, what we have found is the minimum value of f. recall f is not the length of the ladder. F, the square root of f, is the length of the ladder. So to find the length of the shortest ladder, what we need to do is take this x value and evaluate f at that x value, third root of 2200. And then after we evaluate f, we need to find its square root. So this is the calculation that we need to do. You can either use a calculator or some sort of spreadsheet. I used Excel, and my math lab asked us to round it to the nearest tenth of a foot, and when I do that I get 44.2 feet for the length of the shortest ladder possible.